A warm welcome! I'm the Italian Dev and on my channel I upload weekly web dev tutorial videos. In today's video we are gonna code together a decentralized NFT minter. At the end of this tutorial you will perfectly know how to mint NFTs using Moralis from a Next.js front-end web application. This Web3 application is completely decentralized. We will upload our files on IPFS and then lazy mint the NFTs on Rarible. Now you may ask, what does lazy mint mean? Lazy minting NFTs means that we are not gonna pay any gas fee until we sell them. So at the beginning the NFT is minted off-chain and then, only when it will be sold, will be minted on-chain. So if you wanna start your adventure in the NFT world for free without investing any initial money, lazy minting is the right strategy for you. In this way you will defer all the gas fee only when you will sell your pieces of art. If you like this type of content, please subscribe to my channel and hit the like button. It will help me a lot face the YouTube algorithm. Enough said, let's go straight into the code. I'm really excited to start coding this Web3 application with you. As you can see, I am inside my Github account. And I have already created the starter template and load it into the NFT Minter repository, so you can navigate to this repository, and I will leave this link in the description down below. And once you are here, you can download these starter files just clicking this green code button, and you have three options to download this repository. One is to download the zip file, another one is to open this repository with GitHub desktop application if you have it already installed in your computer, and the third option, that is the one I'm gonna use, is to copy this URL, open a new terminal window, navigate inside the desired folder in which you want to clone this repository. I'm gonna choose desktop. And here you can clone this repository, just typing git clone and paste the URL you have just copied. As you can see, an NFT Minter folder show up on my desktop, so I can navigate into this folder and open this project inside Visual Studio Code. The first thing we need to do once we are inside Visual Studio Code is to open the integrated terminal and type the command npm install, so to install all the dependency needed for this starter template I've created to run correctly. Now, why have I created this, let's say, starter template? This is just a simple Next.js application with Tailwind CSS already configured, and I've created two components. One is the auth page.js, and this is the screen that will show up when the user is not authenticated to our application. As you can see, we have a container that takes the entire screen in height and width. Then we have a simple logo at the top, an H2 tag saying mint your NFTs now for free, and then we have a button without any functionality right now, so it's only HTML and Tailwind CSS utility classes, so to give a little bit of style. So we will work with components a little bit, let's say, more visual appealing than the not styled one, saying, so this button auth with Metamask. Instead, if the user is authenticated, we will show up on the screen an upload form that is nothing more than a simple form with an input in which the user can type the NFT name. Then we have another input, a text area in this case, in which a user can write a brief description of the NFT, and the third input is the one that accepts as a type file to upload, and then at the end of the form we have a submit button that says lazy mint now. So it will fire up the request to upload first the NFT on the IPFS, Interplanetary File System, then upload the metadata with the token URI of the image we have just uploaded. Again, upload this metadata to the IPFS and then send this metadata to Rarible, so that Rarible can lazy mint our NFT. Then these two components I've just showed will conditionally be rendered inside this index.js file that is our home page and our only route. So I said conditionally render. Why? Because, as I said, we will show the auth page if the user is not authenticated, else we will show the upload form. Then I've created the custom underscore document.js, and I've created it just to inject again some Tailwind CSS utility class to the HTML tag component, so to have a nice gradient background from Indigo 400 to Indigo 200, and then to apply these hreful utility classes to the body tag. Then, as always, and as any Next.js web application has, we have our underscore app component that will allow us to wrap our entire application with the Moralis provider we will configure in the following minutes. And inside this underscore app.js we import the globals.css style, and these files in which we declare the three Tailwind directives Tailwind needs to work properly. So now we can just, again, inside the terminal, type the command npm run dev, so to fire up the Next.js server that will serve our application under the port local host 3000. So in this way, I will show you the components I've just described with words. So as of now, as you can see, I'm toggling the two components inside the home page, just commenting and not commenting it. As of now, the auth page is commented, so it's a comment not showing up, and the upload form so is showing. As you can see, we have this simple form with a logout button at the top. Now, this form, I just modified some pre-made components that for free are available at this website, tailwindui.com. This is an amazing website made by the creators of Tailwind CSS, and it consists of pre-made components. Some are for paid subscription and some are for free. So these forms come out from this one. This is a 2-column cards I've just removed, and we have one single column with a little bit of modification, and so this is our end result. As you can see right here, you can choose the code you want for HTML, React and Vue, and here you have the preview, and inside here you can grab the code you need. Then if I comment this component and show to you the auth page, as you can see, we have a simple logo, h2 tag, and a button that will trigger the Metamask authentication. These components come from, let me find the forms here. Sign in and registration is just this one, but again, simplified because we don't need any input, because the user will not authenticate by inserting his credential. We don't have a remember me checkbox, neither the forgot password, so it's just logo, h2 tag, and the button. So now we can close that panel, and what we can do after I show the code base we have is to start to think what we have to do. So first of all, we need to complete all the authentication flow. To do this, we need first of all to navigate to the Moralis website. I'm not going too deep showing all the Moralis features, because really the ecosystem is growing day by day, and the methods they provide us are a lot. If you want to know more and to go deep, you can find on my channel previous video I made. One video is more than 2 hours long, in which we can build together a Web3 dashboard from scratch, in which I will show you how to authenticate with Metamask, how to show all the crypto that follow the ERC protocol inside the user wallet, the last transaction on the Ringbit testnet network, the NFTs, and also how to send Ethereum from a Next.js front-end web application. Then there is also another video in which I show you how to authenticate Solana user using the Phantom wallet. And in this case, as I said, I will show you how to lazy mint an NFT on Rarible. So if you don't have an account, you can sign up for free clicking this button. If you already have one, just click on login. I have one, and insert your credential and log in. So once we are logged in inside the Moralis dashboard, what we need to do is just to create a new server. We're gonna choose mainnet server, give to this instance a name. I'm gonna call it NFT Minter. Select a region, the one closest to your location. Mine is Frankfurt. For select network mainnet, it's okay. And again, select Ethereum mainnet. So time to click at distance, and in a few seconds we have a complete Web3 infrastructure ready to be exploited for development purpose, but also it's production ready, and so easy to scale to. Now that we have this server created, we can go back to Visual Studio Code, stop the server, and install the two packages, two libraries that we need to glue our Next.js application to the Moralis server we just created. So inside the terminal, type the command npm install Moralis and React Moralis. Now that these two packages are installed, we can navigate inside _app.js, so to wrap our entire application inside the Moralis provider component. I have auto import set up in Visual Studio Code, and so now we can move our entire application inside this Moralis provider. As you can see at the top, we have Moralis provider imported from React Moralis, the package we just installed. What does this Moralis provider component do? As the name said, it's a provider which we can consume inside all our components where we need. This Moralis provider, to work properly and to connect properly to the server we have just created, needs two props. One is the app ID, application ID, and the other one is server URL. Now, when we have values like this, it's common to create them and to handle them through environment variables. To create environment variables inside the Next.js project, what we need to do is to create at the root level of our application folder a new file called .env.local. Inside this file, we can define our two environment variables, and we need to prefix them with the prefix next_public. What does this prefix do? This prefix just tells Next.js that these variables we are gonna create are safe to be exposed to the client. That in case we are browsing through our browser, it means simply that these environment variables are safe to be exposed to the browser. So let me just copy paste, since we have two environment variables, and the first one is next_public_app ID, and the other one is next_public_server URL. Now it's time to grab this value. Now you may ask, where these values come from? Easy. We need to go back inside the Moralis dashboard. Here is the server I've just created, and I need to just click on this button, View Details, and the Server Details model will show up, and we have all the option values we need for our server. In this case, we need just the server URL and the application ID. So let's start by grabbing the server URL back in Visual Studio Code and paste inside here, and then it's time for the application ID, again copy and paste just right here. So now we have our two environments set up, and we need just a bit of copy-paste more work, so to avoid any typo. So let's start with the application ID, and so it's equal to process.environment.paste nest public app ID. So we can copy this one with the curly braces too, paste it right here, and instead of next public application ID, we have next public server URL. So now we have our Moralis provider correctly set up inside our Next.js application. So we can start to think about our authentication flow and how to handle it. So let's go back inside our home page, inside our Only route, and we've said from the beginning that inside this home page component we are gonna render conditioning or the auth page or the upload form in base of the user is authenticated or not. So now the question is how to know if a user is authenticated or not. Well, Moralis comes in help, and React Moralis comes in help, so we can define inside this component const curly braces, so it means we are gonna destructure some value from somewhere else. From where? From use Moralis hook. This use Moralis hook, really, it's full of useful methods and useful values that will allow us to handle almost all the Web3 related stuff we need to perform inside our Next.js application. So we can start by destructuring from this use Moralis hook. So consume, as I said before, we can start consume this provider inside our home component thanks to this use Moralis hook, and we can start from a boolean value that is called is authenticated. So thanks to this boolean value we are able to know now if a user is authenticated or not. So what we can do is to just through an if statement say if the user is not authenticated, return, and so show on the screen what? An auth page. So in this way we will allow our user to auth. Else, and here as you can see we have an implicit else, because since we have just two values from this authenticated, true or false, there are no other options. So if this is true, perform this, else show the upload form. So now if everything works fine, let's say we can again fire up our server and expect to see the auth page screen showing up because we are not authenticated. And look, under localhost port 3000 we have the auth page correctly showing. So now that this if statement works and the Moralis provider is correctly set up, it's time to hook up to this button the authenticate method. So how to do it? Here again from use Moralis we can grab what? The authenticate method, and so define a custom function that we will pass to the auth page, and we in the way that we can exploit this custom function inside the auth page component. So we can create a new custom function, as I said, const metamask auth is equal to an asynchronous function in which we will return a try catch block. We are not gonna do any, let's say, pretty error handling for this project, but now you know the basic and all the stuff you need to show. Instead to console log the error, you can fire up a toast or show an error on the screen. So inside the try, what we can say, await, since we are always handling a synchronous function, await what? Authenticate. And to authenticate, we can pass some option. One, just to show you, is the sign-in message that will show up inside the pop-up Metamask window when we will sign our transaction. So we can ask to our user auth to start lazy minting your NFTs. So now we can pass this method, this custom method we have created inside the auth page component that will receive it as prop and navigate inside the auth page.js component, the structure from the props, the method we have just passed, and navigate down till we reach the button HTML tag saying auth with Metamask, and so we can pass to this button the onClick JSX attribute and say what? Say it's time to perform the Metamask auth. So you know what to do. So we can let me explain this continuous warning showing up before we move on. I think this is something that at Moralis they will fix later or soon, and it's asking to install two packages, Magic SDK and Wallet Connect Web3 provider, and it's always showing it as a warning, but we don't need these two packages, so I'm not gonna install it. It's for, I don't know, it's kind of my principle. I'm firm to this decision. I don't need it and I will not install it. So you can keep blaming on my terminal window. And since we don't need to do any kind of work inside our terminal after the server, we fire up the server with the npm run dev command. I know it's a little bit annoying to see this stuff always on the screen, but this is what it is. So if we navigate back to our website, now this button should know how to authenticate us. So if I click, look what happened, a MetaMask pop-up window will show up, and as I said, we define the sign-in message as an option parameter inside the authenticate method, and didn't ask auth to start lazy minting your NFTs. So let me just sign, and now, as you can see, we are seeing on our screen the upload form to show you clearly that we are authenticated to, oh my god, that's so huge, authenticated to this application, and we can navigate in the developer tool under the application tab, and if you open the local storage, localhost 3000 panel, you can see right here that we have this auth data object saved right inside our local storage. As you can see here, this is the Ethereum address I used to authenticate, and I can show you, look, 0029. If I open Metamask, you can see 0029, it says connected, in Italian is connesso, and some other stuff like session token, object ID that Moralis needs to keep track of our session. So if we have this data right here, what we can do, we can refresh the page, and we are still authenticated. We can close this panel, open it again, and we are still authenticated. So now that we know how to authenticate user, we should close our authentication flow, giving this button the capabilities to delete that auth object that lives inside the local storage I've just showed, and so kick us out from this web application, and so log out. Open again Visual Studio Code, and we can move back to index.js, so our home page, in which we started consume our Moralis provider, and we can grab from, again, use Moralis, the logout method now. So we know that the logout button lives inside the upload form.js component. So what we can do, just the same as we did before, we can pass this logout method as prop to the upload form component, go navigate inside the upload form component, the structure, this logout method we have just passed from the props, and take this logout method, find the button, this one right here that says, hey listen, it's time to log out, and again define an onClick JSX attribute and paste the logout method we have just passed to this upload form component. So now let's navigate back to our browser so we can test what we have done. And so let's open again the developer tools panel. Under the local storage, like I showed before, we still have this auth data, and now if we did everything right, if I click this logout button, this auth object should be clean from our local storage, and we should be successfully log out from this decentralized application. So you take a look here, while I'm gonna click on the logout button, and look what happened. Log out, look, the auth object used by Moralis to keep track of our session disappears from the local storage, and the sign in, the auth page will show up again. So let me log in again. So we have our upload form, and look, so easily a complete authentication flow is handled by Moralis, and so we have injected a Web3 authentication inside our Next.js application. So what we need to do now is to give life to this upload form, in which, as I said, the user can give a name to his NFT, give a description to his NFT, and upload the file, just clicking right here, and as you can see, it will allow me to upload the file I choose as NFT, and then click in this lazy mint now, make this NFT be listed inside on Rarible, lazy minted on Rarible, sorry, not listed, because you have, as you can see later, you have also the option not only to lazy mint on Rarible, but also to list it, so the NFT will be already on sale on Rarible. So, time to go back to Visual Studio Code. We can close this one, this one, this one, we don't need it, and so now we are inside this upload form. What we can do before is to keep track of everything is inserted in, is typed in our form. So we need to keep track of this input for the name the user have chosen, and this text area for the description. Instead of creating a state, a different state for each of them, and so a different onChange method to keep track when user is typing or not, we will do it in just a single state. So let's start by creating this state. So const input and set input, and this is equal to use state auto import, and inside we have an object with what? A NFT name, name key, and description key. So now these values, you can call this key in an arbitrary way. So you can call whatever you want. But if you want to stick with this component I already started to code, so this starter template we are coding together, if you are following along, this name has to be exactly the same. Why? Because this NFT name key I've defined inside this React state is the same of this name attribute passed to the input for the NFT name, and the same is for the description. Right here, as you can see, I have name description, because what we can do, we can create a custom handle on change, so const handle on change, and this will receive the event as parameter. And so inside this handle on change, every time is triggered with a new event, we set the input, so set a new state. And to set a new state in this way, we need to firstly take the previous state. And you know that set input provide us a previous state as parameter. And so then to have a new callback function in which we define the new state. And how is composed the new state? The new state is simply composed by the previous state, so we spread the previous state inside this new one, and then we say take the name I'm changing right now, so the property I'm changing right now, and to do this we define e.target.name and set it equal to e.target.value. So now I will show it you once we will console log this to the developer tools. So let me just type console.log input. Now let's wire up this new state and new method that we have just created together inside the form. So the input with the name property NFT name, we pass a value. So passing the value means that this input now is passing from an uncontrolled state to a controlled state. So means that we are controlling the state of this input with the React state we have just created. So inside this value we pass input.NFT name, and then on the onChange.jsx attribute we take the event and we call the handle onChange passing the event. So now we can do the same for the text area, and again we can just copy paste, but in the value instead of passing the input.nft name we pass the input.description. So now let's see how it works. If we navigate back in our browser, and again opening the developer tools, you can clearly see what we have just done. Now I have an error because, as I said, the component now is changing from uncontrolled input to be controlled. So if I refresh the page, this warning goes away because now we have controlled input. So we are not changing the controlled state of this input. Now they at any refresh they will always be controlled. As you can see, we are starting from this default state. So NFT name is empty and description is empty. Here you have NFT name empty, description empty. If I move inside the NFT name and start typing, what I do, look what happened. NA, as I'm typing, is being set to the NFT name key and the description is still empty. How this is happening? Well, because, as I said, in our handle on change, we are taking the event. First of all, we are passing the previous state, so it's meaning that we are passing this NFT name empty right there, this description empty right there. Then we are just checking which input is changing in base of the e.target.name is changing the NFT name, so this one. And so we are setting the value equal to the e.target.value, in our case is A, and the description still remains empty. So it means if we didn't pass before to start modifying the value that is being modified at the previous state, means that in that way we were going to lose the state of the description, because now look what happened. The description is being correctly handled and the NFT name still remains A because we are passing the previous state. So perfect. Now we know that our input is correctly working. To finish the setup of this form, we need just to keep track of the file, so when the file is uploaded. So in this case, we can create a new state up right here, and we can call it our input file and set input file. And this is equal to use state, and let's start with the null as default value. Then we can move down till we reach the input in which we handle the file upload, and again say to this one, listen. So on change, when you are changing, take the event, in this case do what? Set input file. Okay, the setter we defined up right here, and set it equal to what? e.target.files is an array, and we need to grab the first element of this files array, in which lives the file we have uploaded. And so, to show you that we are correctly grabbing the file from that input, we can just console.log what? Input file. So let me save, go back to the browser. As you can see, starts from null, as we defined in our default state. If I click upload, I'm choosing the only image I have in my downloads folder. It's just the cover image I did for the previous video. Yeah, it's related to the auto-authenticate Solana user with Fandom Wallet I was just saying before at the beginning of the video. If I click open, look what happened. The file object correctly show up here. We have name, size, type, and everything we need. So now, our upload forms has everything it needs to work properly. So all we have to do right now is that to give the capability to perform all the Web3 stuff we want to perform on click, so on submit. Now, as you can see, it's not acting as a JavaScript submit because it is posting the file we have, the values we have just defined, but we don't need to post any value. So we can now go back to Visual Studio Code, just remove this console log, we don't need it, and start to work on the submit. So on the form tag open, we can define the the form disappeared. We can define the onSubmit JSX method, take the event as always, and start to code. The first thing to avoid the problem I just showed you, so to post something, is to prevent the default behavior. How? Simply typing event.preventDefault. So now that we know how to prevent the default value, we can start to think on what we have to do. So the process that will bring our image to an image that I'm uploading to this front-end web application and go all through the Web3 process till it reaches the Let's Mint status on Rarible. To do this, since we are gonna do it in a completely decentralized way, so it means this image will not only live in this case it's my hard disk, or could be I don't know, somewhere on the cloud, but let's say we want this image to live in the interplanetary file system, IPFS, and you know is the decentralized protocol that handles file storage. Then once we upload the image to the IPFS, we will have an hash that will tell us in which location this image lives inside the IPFS. So once we have the location, we can upload something else to the IPFS. What? The metadata related to the image. And the metadata related to the image will be the name that we grab from the input, the description that we grab from the input, and the image, the token URI. So the position of the image in the IPS world. Once we have this metadata, this JSON object is nothing else than a JSON object, and we are calling it metadata just because it's linked to an image, but it's nothing else than a JSON object. Once we have this JSON object upload inside on the IPFS world ecosystem, we can then exploit the URI, so the position in this case of the metadata inside the IPFS ecosystem, and give and pass this data to Rarible. So Rarible knows how to grab the metadata, and knowing how to grab the metadata, Rarible will know the name of the NFT, the description of the NFT, and also the image position of the NFT. So this is the flow that we need to handle, that we need to face. So just to have everything clear in mind, let me briefly repeat again. First of all, upload the, let's talk in this case image, you know the NFT could be image, JPEG, whatever you want, GIF, we are talking about image. So upload this image to the IPFS, then upload the metadata related to the image again to the IPFS, and then let Rarible know and pass this metadata to Rarible. So let's start by saving the image we are able to grab from the form on the metadata. To do it, we can exploit a method given us again by Moralis, but in this case this method doesn't come from the useMoralis hook, but comes from another hook. So again, the structure what? Use Moralis file in this case, and from use Moralis file we grab the save file option. So we can now move back to our onSubmit method. Let's perform a little bit of check. It's not in the scope of this course how to handle properly a form, but let's suppose that everything works, we have a file, we can just do a simple check saying if input file is not equal to null, so it means if we have something, but there are better way to perform form validation, what we can do inside here? We can await, so it means that we have to change the type of this function. It's not a synchronous function anymore, but it's asynchronous function because we have an await, so we need to wait for something to perform, and we can just call the save file method. This save file method takes, as you can see, a name as a string, and we can, it's not relevant, but we can just pass input.nft name, and then we need the file that is of type file input, and we can pass the input file, and then an option object in which there is the save IPFS key, and we say true, because this save file works also to save file to the Moralis database, because with the server instance we fire up at the beginning of the course inside the Moralis dashboard, I said this is Moralis will build a complete Web3 infrastructure. So we not only have the server, but we also have a Mongo database. So with this method save file, we can also save file to the Moralis database, the MongoDB database Moralis provide us. But we don't want to save this file to the Moralis database, but we want to save this file to the IPFS, Interplanetary File System. And then we have also an unsuccess. So this receive a callback function and just say if this works fine, and so we are unsuccess, we will take the file back, and just for now, to see if everything is working fine, let's just write console.log file. Okay, so it's like a response, okay? But in this case it's attached to a type that is called moralis.file that has an hash attached to it and _.url. So as of now, let's see if we are able to upload this image to the IPFS. There is also a non-complete on error again. If there is an error, you can console log something else or show a toast an error message, but as I said, and I'm not tired to repeat it, we are not handling error in the proper way. So save. Let's go back to our web application. Upload, I'm still using the same image. Click open. So now this is upload because I showed you in the console. So now we can say, maybe let's do a little trick here where we are showing this SVG. So just to visually know that the image is, that the file is uploaded. So here, let's do a ternary check. So say if input file is not equal to null, show something, empty string for now, else show something, empty string for now. So if the input file is not equal to null, we can just show what paragraph tag with the input file dot name. So we have an input file. Else, if we don't have an input file, show this SVG asking us to add the file. So we can cut this and paste it right here. Let's see. So now if we go back, look, we don't have anymore that SVG, but we have the name of the file we have just uploaded. So now let me open again the developer tool panel, clean, and if I click on lazy min now, I have an error. Why? Why? What is happening? Where is? Let me pass also the on error method so we can console log the error and see what is going wrong. Console log error. Let me save and try to lazy min. file name not provided. Ah, yeah, it's right, because we don't have the NFT name, because I'm providing here the input.nft name that now is empty. Right. So let's put just a simple A to test it, and let me lazy mint. Look what happened. We have back this data, but what we just need is this hash string value, because if we copy this and open the Brave browser, we can type IPFS / and paste the hash code, and as you can see, our image is correctly loaded on the interplanetary file system. Cool. So now we know how to upload, to upload this image to the IPFS. So the first step, to upload the file, is successfully done. Now we need to upload the metadata to the IPFS, and it's just a JSON object. So on success, instead of just console logging the file as we just did, now we can perform the upload of metadata. So if the image is successfully loaded to the IPFS, I can move on, and now I can upload the metadata to the IPFS. So let's create a metadata object. It's just a JSON object, and does a name key as input.nft name, then as a description as input.description, and then as the image property. So in this way, Rarible will know where to grab the image, and is equal to /IPFS/ plus, so we are concatenating to string what the hash I just showed you before, so it's equal to file._hash. Okay, so now we have this metadata object. So just to do a little bit of check, and so to avoid the error I just had before, let's say also if input.nftName.trim open parenthesis not equal to an empty string, and input.description.trim again is not equal to an empty string, do what you need to do. So now that we have this metadata object, we need again, as we did for the image, to call this save file method, but instead of passing the input file, now we need to pass this metadata object. So what we can do is to call again and await save file, and give it a name. In this case, instead of just giving the name of the image, let's give as a literal metadata, and pass the $, the input.nft name. So it's not only, as we did for the file, the name of the image, but it's metadata plus the name of the image, and then we need to pass the file. But instead of just typing comma, as we did up here, comma and the name of the file, so comma and metadata, we can do it, because we need to transform this JSON object into a base64 string, because this is the format file accepted for the JSON object by the IPFS. So we open curly braces, we have this base64 key, and we say that this base64 is equal to BTOA, that is the JavaScript method, means binary to hash, and we pass to this method what json.stringify what the metadata. So now we are passing, as I said before, the name of this file and this metadata plus the name of the file, and then we are passing this object as base64 string, and then we can pass, as we did before, an object parameter in which we define save to IPFS true, so we will save this this metadata object to the IPFS, and again we have the onSuccess callback method in which we define what we will have back what, let's call it metadata file, and for now, hoping that this time works and we don't need to code the onError handler, we can just console.log the metadata file, and we expect, do I have an error? Yes, because again this function, this callback function as on success now is asynchronous, because we are calling inside an asynchronous function again save file. So fixed that, we need to expect an object like the previous file, so again with an hash, and so we can navigate to IPFS to that hash, but instead of seeing now the image, we need to see just a JSON object, like the JSON we receive as response from when we make a call to a server or a database. So again, let's write test 20, test 20, test 20 as description, upload the file, it's already uploaded because I didn't refresh the page, and if I click lazy mint now, oh cool, now this time works. So I have back again this object on the underscore data, underscore IPFS, name, source, and everything else. Look, format base64. So we are passing this JSON object in this base64 form. So we can copy again the hash, open Brave browser, and type IPFS // paste, and if I enter, it may take a few seconds. Look, instead of retrieving the image, now we are retrieving an object, as I said before, in which we have the name, the description, and also the URI of the image. So if we copy again this hash, and it's the one we received when we upload the file, and open a new tab by IPFS just to show you that everything works, and paste the image IPFS hash, look what happened, we have the image. So now we can pass this metadata object to Rarible, so Rarible will know the name of our NFT, the description, and also the image where to grab it. So let's do it. To do it, oops, it's time to go back to Visual Studio Code and grab another method from React Moralis. This one is use Rarible lazy mint. Let's see if it's imported. Yes, it's imported. And we can start passing few, let's say, default parameters in this case. And choose as a chain the ring B chain. Then we need the user address, so who is creating the this NFT, and we can grab easily the user address from, again, use Moralis in this case. So we can go back to our home page in which we are consuming the Moralis provider, and from use Moralis grab the user object that is of type moralis.user, take this user object and pass as a prop, as we did for the logout, to this upload form. So now we can move back to upload form, and instead of destructuring just the logout, we can destructure the user object we have just passed and pass it here and call the get method on it and get what? The Ethereum address. So now Rarible will know on which chain we are working. As I said, Ring-B, because we don't want to pollute the mainnet. Let's just work on the Ring-B net for development. We can also use the mainnet because, as I said before, we are doing the lazy mint, so we are not paying any gas fee. So we can also test it on the mainnet, since we are not gonna pay any gas fee. Because the lazy mint, what does? It's just, let me try to explain in simple words. Uploads the NFT and off-chain. And once there is a new buyer, it will mint it and mint on chain. And so you will pay the gas fee only at the time there is someone will buy it. So it means it's just like you are deferring the gas fee. And for many artists, users, and the one who are just making their first step on the NFT world, is a really nice option, because it allows you to lazy mint a lot of NFT without invest any initial money, and then you will pay this fee only if you will sell it. So you can start this your NFT adventure practically from free. Then we need to define what? The token type, and as it shows up, we have to choose two protocols. One is the ERC1155 and the second one is RC721. The main difference between this protocol is that the ERC1155 allows you to have a supply different than one. So it means that you can have the same NFT, you can have more, not just one, as it is for the 721 IRC protocol, which is just that NFT, and you can have more. So it's we are just setting a supply equal to 1 again, just to don't pollute the Ring-B test network for Rarible, sorry. And as I said, you can pass the supply, and I will put 1, but you can have 100, 1000, 10,000 in base of your needs. But if you set the protocol equal to RC721, the supply is just 1. Then another option you can pass is the royalties amount. So you can define the royalties on upsell. And passing the value of 10 means that every time the first seller will sell your NFT, you will grab the royalty as creator and then set it to equal 0.1. If you put it equal to 5, it's 0.05, to end it's 0.2. For this, let's just set equal to 10. And then this use Rarible lazy mint will give us back a lazy mint method that we can call when we will submit, when the metadata are successfully uploaded to the IPFS ecosystem. So here on this onSuccess callback, we can call the lazy mint method. But before to move on and to perform this last step, we need to do a little bit of more configuration inside Moralis. So open the browser, navigate again back to your Moralis dashboard. Let's refresh just to be sure we are still logged in, and we need to install a plugin to our server. So let's open this panel for our NFT Minter server. We have a plugins button, just click on it. This will fire up a model, find new plugin. Now we have just the core services plugin installed. Click on go to plugin store And here you can find a lot of plugins, the Painata IPFS, the Covalent Moralis plugin, OpenSea, buy and sell NFT, on ramps allow you to allow your user to swap from fiat to crypto, so you can put this little widget on your decentralized application that allow your user to swap their fiat in crypto. Then we have also the Lynch Moralis plugin, but what we need is the one I skipped, and I'm saying right now the Rarible NFT tools. So we can just click on here and click on this green button, install the plugin, select server, so NFT Minter. We are gonna install this plugin to our server, and now to configure this plugin and let it work, we need to pass the Ethereum mainnet speedy node and the Ethereum Ring speedy node. Now, what are speedy nodes? The name is funny, speedy nodes, but it gives it just tells us it's a node. What does it mean? Why do we need this node? Because the Rarible decentralized application, as I said, work on the Ethereum mainnet and the Rarible Ethereum mainnet, and to lazy mint also new NFT needs to have the complete blockchain. So the complete blockchain, so it needs the complete mainnet blockchain, so the archive from the transaction 0 till the last one, and so for the Ring. So we need to have a node from which to communicate, so to open an RPC connection. Now there are many ways to have a node. One is to use other provider like in Fura. You can spin up your own node to run the blockchain on your local node, or you can set up it on Alchemy, but we can exploit the nodes provided for free by Moralis. So they have their own node up and running, in which they have the complete archive of the Ethereum blockchain, and provide us this URL endpoints, which we can establish our RPC connection, and Rarible will establish for us the Rarible plugin. So we can copy this mainnet URL and paste it here, and then paste the one we need right now, because we are working under the Ring network, as we said before, and paste right here. So just click install, and this will now start install the Rarible plugin. If I click, let me see, it's still installing, so the Rarible plugin is installing. So while it is installing on our server, we can move back to Visual Studio Code and call this lazy mint with this parameter, default parameter already set, and move to the on success, the last on success. So now we know that the metadata are successfully loaded on the interplanetary file system. And what we can do now is, first of all, call the Moralis instance. Let me import it and delete these types, because we don't need the type, but we need the Moralis instance. And first of all, type Moralis instance and call the enable web3 method attached to it. And this is asynchronous too. So this on success become asynchronous before to receive any error when we will run it. So this command will enable web3. So we are now allowed to perform this transaction. Then we call the lazy mint method, again await, and pass to this lazy mint and additional parameters now. So params. So now to this lazy mint will fire up with this default parameters we have set up right here, plus what? the token URI. So Rarible will know where to find this metadata file on the IPFS ecosystem storage. So again, dash IPFS dash plus concatenating. Before we pass the file hash, so to grab the hash file and paste it into the metadata, now we need to grab the metadata file hash. So metadata file dot underscore hash. Now, again, if this will correctly work, we will have an unsuccess callback function. And in this case, it's like having back a response from Rarible. And let's just console.log res. Okay, so now we know how to interact with Rarible and how to lazy mint the NFT on Rarible. So let's see if perfect. So the Rarible plugin is installed correctly. So we can move back to our web application. Let's refresh it to have everything clear. So the state is clear, the React state. Open the developer tools and hoping to see printed out right here the successful response we received from Rarible. So for this one, let's do a test 1000, sorry, again test 1000, test 1000. Upload what? Always the same image. And now if I click on lazy mint now, again the process, sorry if I repeat it, but it's, how to say, better to have clear in mind the whole process. We'll upload this image to the IPFS, then we'll grab the hash, so the position inside the IPFS, and put it inside the metadata with this name and this description. Upload the metadata to the IPFS, and then once we have the metadata uploaded to the IPFS, we will grab the hash of this metadata object on the IPFS, and we will tell to Rarible, hey Rarible, go. This now is done on the Rigby testnet. We will tell to Rarible, hey, go to this IPFS position, grab this JSON object in which you have the title and the description of the image, and you have the image position on the IPFS, and lazy mint it. So, thanks to the speedy nodes we just set on the Rarible plugin, we will communicate to this node, and so this node, what we will do? They will take this transaction, broadcast inside the other nodes that takes not all the nodes, but some of the node that takes the blockchain alive, and then we'll lazy mint this NFT on the Ethereum blockchain. Again, the Ringby Ethereum blockchain now. And so if I click lazy mint right now, all the process I just described will fire up. Let me just check again if everything works fine. So we have the use Rarible lazy mint chain, look, not Ringby, but Ringby with the user address, user.get Ethereum address, token type, IRC1155, supply just one to not pollute the chain, royalties amount 10. And if I move back to where we call the lazy mint, we enable before the Web3, so to perform this transaction, we pass the additional parameter token URI with the IPFS prefix but the metadata hash file, and if everything works fine, we console log the rest to the console panel. So let me try, we have everything, so lazy mint now. All the process is happening under the hood, and let's see if the correct response will show up. Okay, so as you see, we need to confirm the transaction with this token ID. The token URI points to the metadata. Let me show you again, just to be so sure. So we are passing this token URI, like IPFS double dot paste. And look, cool, nice. Where is here? Okay, nice. So this is the account, this is my Ethereum address. So I'm creating this NFT, the royalties set to 10, and let's just sign this transaction and let's see. Now the nodes, the speedy nodes, are broadcasting this transaction through all the other nodes, and look, we have a success, true. And here, as result, we get back a token address and the token ID. So now let me close some other panel to have everything clear. So what we can do, we can move, we can navigate to the ringb.rarible.com, because again, as I said to you, we are under the ringb testnet, and open just to see the URL, another NFT on the ringb network. And as you can see, the ringb URL is composed by this ringb.rarible.com, then there is token attached to it, and then there is this value starting from 0x62 that seems more like the token address, so 0x, and then we have a double column and another long string value with the query tab owners attached to it. So we can remove this one, we don't need, and so we can paste before the token address, so copy string content, and this is the value before the semicolon. Let me remove this one and paste the other one, and then we have the token ID here. And let me copy the string content, and this goes just after the semicolon. Let me delete and paste. Now if I press enter, look what happened. Cool, perfect. We have this test 1000 as the name, then we have test 1000 the description, the creator royalties 0.1, the owner me, and here is the NFT we just successfully lazy minted on Rarible. Really, I'm so happy to have built this with you. And now you can move forward, because what you can do is you can not only lazy mint, but there is also from use Rarible lazy mint, there is also the you can grab the is loading value. So when it's loading, what you can do is to disable the button. You can show an error if you can so perform the validation inside, or on success you can then dynamically build this URL just passing what this base URL right here, and then append to the URL this value right here, the token address and the token ID, and show this in maybe in a toast. You can do whatever you want. You can also how to say improve this form. Maybe you can put the checkbox inside in which people can choose what type of token type they are chosen as protocol for the NFT. So give them the option to choose between ERC1155 and the 721, and then also implement the validation and say if you have chosen an ERC1115, you can put a number input in which they can choose the supply, so from 1 to whatever they want. And also if they instead opt in for the ERC721 protocol, this input is fixed to 1. Then you can also allow them to have again another input field in which they can type the royalties amount they can choose. Don't put any any wall, any limit to your idea. Keep building, keep exploring, and really, if you follow along with me and you improve this decentralized application with form validation, and maybe the idea I gave you to improve this form or to add something else, really, I would like to if you show to me your project and leave the link in the comment section down below, and that will really help to check what we have done. Thank you very much for watching. Always, it's a huge pleasure for me to share these small things I know. And if you think this video can be valuable in some way to you, click the like button, subscribe to the channel, it will help me a lot. And again, remember, in the comments, share all your project, your idea. I will be happy to talk to you, and also maybe to collaborate, to work together on something. Thank you again for watching. The Italian Dev. Bye bye.